I'm going to take you back to 2014, actually. I was working inside of this building. It's actually on the, it's a funny thing, it's on the border of Germany and the Netherlands. So it's right on the border, right? So the actual border is here. So it splits the building in two halves. So we were working here in this office, in this corner office. If you need to go to the bathroom, you actually need to go to Germany. So you need to bring your pass or whatever to go to the toilet. So we were sitting there in that office, and it was a pretty small company, but we had some large customers, right? So we were working for large petrochemical companies like Shell, BP, Exxon. I don't know if I'm allowed to tell their names, but it doesn't matter. And we were writing software for them. And we were there. We started in, I think, 2008. And we started in a small building here. And this top left corner, we're sitting there. And we've been writing code for like 6 years, and the code grew and grew. And at one point, I was sitting there on a desk with one of my colleagues looking at some code, and I'm actually like, yeah, what does this code do, right? It was so intensely complex that I looked at it and I said, well, that's because you're not a genius, and only geniuses can control chaos. So yeah, he obviously was a genius, at least he thought he was, and he wrote that code, and it was really, really hard to understand, right? So what defines a genius? So that's the question, right? If a genius can control chaos, if we're geniuses, if we're all geniuses, that's not a problem, right? So an actual, one of the prerequisites to call yourself a genius, if you would like to do that, is that you have like an IQ over 140. So this is the bell curve, displaying the IQ, obviously. And so you would be around here, right? This piece of the bell curve. So that actually means that maybe one person here in this conference, it's an IT conference, so maybe a bit more, right? Actually has an IQ higher than 140, but most of us probably don't, right? Yeah, I know, Sander, you do. I know. But still, right? So if only geniuses can control complexity and chaos, and most of us, including myself, we aren't geniuses, what should we do, right? What's next? What should we do? So I'm Rob Geurden. I'm an independent software developer. I work at a company called iBoot. We're a Dutch e-commerce company. I was actually hired by Sander, who's doing the keynote. Yeah, and if you want to look me up, there are some links for my socials. So in order to know what's complex, right, you need to know the characteristics. So we've probably seen the opening keynote, talked a bit about it. So this is a sort of maybe small repetition, but maybe it sticks better, right, if you repeat stuff. So what are the characteristics of overly complex code? So basically, when I started fresh out of college, I started with writing super simple code, right? Most of us probably do. I started off here, so writing simple code. It was very procedural most of the time. It was pretty easy. It was long code, but at least it was fairly easy readable code. Then at one point you actually found out that there was something called object-oriented, and you start applying that to nearly everything, right? So even places where it might not be needed. Same goes with design patterns. So design patterns are cool. You just need to know when to apply what. So it's not a silver bullet, not a single design pattern you can use for nearly everything. You need to know when to apply what. And yeah, I obviously didn't, so the code grew more complex. And yeah, abstractions, interfaces. And at one point I thought, yeah, this is enough, right? And then you see over the years, you go back to simple code, right? It's not the simple code you write here. It's different, but it's still simple. They don't overlap, but at least you try to avoid complexity, and you know what complexity is, and you try to avoid it. So that's what you get usually. So yeah, we already heard Victor also talk about that. So one of the characteristics, one of the things you usually see in a code base which is too complex is that classes and functions are too big, right? So you're right, also already there. So usually they say like a function should be below 100 lines of code. That at max, right? That's already really big. I actually Uncle Bob says 20 max. But still, I think, and that's also something we learned from Sander. He says, yeah, stop with that. Just start with a return, right? So make your function easy. Make it one line. Try to always start with a return. Write it a bit more functionally, and you'll get easily readable, maintainable code, right? So that's my advice to you. Try to start your functions with a return. It will make your code more readable, easy to maintain, and just better. It will make it shorter. So going back to 2014, I actually had the source code on one of my USB drives, which we wrote back then. And for this conference, I thought, yeah, wait, this is like 10 years ago. Was it really that complex, or was I just not capable of getting it back then? So I actually found the code and ran some code analysis on it. I'd advise to do this on your code as well, right? Run some static code analysis on it, because it will give you a hint of in what kind of shit you are, right? So I actually found the function we were looking at. It was the refresh schedule status. It's a really bad name as well, so don't look at that. It was VB.NET code, which is worse as well. And the single function had 488 lines of code, right? So that's pretty huge. And I actually have the code here. I wanted to show you what that is, with the risk of getting repetitive strain injury from scrolling. So let me show you how it looked like. So where is it? It's here. Get it up to the other monitor. So I don't know if it's readable, but at least you can see how big it is. Wait, is my mouse? Oh, my mouse is scrolling the wrong thing. So it started roughly around. Wait, it's not there yet. Yeah, so here. This is the start. So this is what we were looking at, and then scrolling down. So this is a single function, right? So yeah, probably if you're genius, you will also have a hard time reading this, right? So I'll stop scrolling. You get the picture, right? So let me go back to the presentation. So yeah, you actually see that 100 lines is probably also really, really big, right? So try to aim for a single liner. That's best. So yeah, single responsibility principle. Obviously, that function I just showed you did more than one thing, right? So yeah, that's clear. If you write long functions, they're probably too big because they do too much. Well, and that leads to another thing, which is called high cyclomatic complexity. Do you guys know what cyclomatic complexity is? You see some hands, so I have a rough idea. Yeah, okay, so it's nearly like a quarter. Okay, so if you write a function, every if statement you create, right, creates two paths you should test, right? You should test the if, and you should test if the if is not true, like the else, for instance. So cyclomatic complexity gives you a number of how many test scenarios you should write to basically cover your entire function, right? And the thing is, if your cyclomatic complexity is too big, you're obviously breaking the single responsibility principle because your function is doing too much. You have too much test scenarios for one single thing. So keep in mind that everything you do, like for instance an if statement or a while or case, that increases your cyclomatic complexity. So an if statement, single if statement, increases your cyclomatic complexity by 1. If you do a do loop, you also have two. I actually never do a do loop, by the way, but if you would do that, you also have two. You also add a cyclomatic complexity of 1, right? Because you're either inside of the loop or you're out. So that's also another path you should test. Case statements, that's a different beast. I think Victor said if you do a case statement, then that's the only thing your function should do, right? And that's because of the cyclomatic complexity. Because each case you'll add to that statement creates another test path. So if you have 4, you basically have 4 test paths. And then you have 5 test paths, because also it couldn't fail within the boundaries of that case. You need to test that as well, right? So the thing is, cyclomatic complexity, you need to keep that low. So there's some numbers. This is a graph made by Tom McCabe, Department of Homeland Security. They actually wanted to know, okay, so what would be a safe limit for us to have on functions, right, the cyclomatic complexity? And they actually defined that it should be roughly between 1 and 10. So if you're there, then you're good. Anything above that actually is too high, right? So with 11 to 20, it's more complex. You have moderate risk. I think it's too much, by the way, so I would keep it below 10. And anything above 50 is untestable. It's basically not doable to get that right. So coming back to the code again, we've written the function I showed you. It actually had a cyclomatic complexity of 107. So that's twice the number where you are at very, very, very high risk. Yeah, and I think it was obvious looking at the code that this wasn't good, right? So try to keep your functions small in order to also keep your cyclomatic complexity of your functions low in order to be able to test them, in order for other people to understand them right. Which also leads to coupling. So if you write a function this big and it's doing more than one thing, you're probably calling it not from a single place, right? That wouldn't make that much sense. That function, no, I'm not going to tell you. I'm going to show you in a bit. So the thing is, you want your coupling to be low. You only want coupling in places where you actually need it. And if you tie everything together, if something changes in your system, right, it could break something else. So the thing is, you only need coupling at the places where you want it. You want to keep it low. You want to keep it very lightweight. And the thing is, if you have long functions doing more than one thing, you probably also have high coupling. So there's an upper limit of 9, which I think is pretty high already. So that actually says that you can call a single class from 9 different places. This is a statistic. This is something Microsoft said in 2010. I think it still applies. I think 9 is too high, by the way. Keep it low. Going back to that code, it had a class coupling of 60. So yeah, that's obvious, way too high. If you change something there, you might hit 60 other pieces of code, right? Which leads to something which is called shotgun surgery. And I think we've all been there. So you do a certain feature, right? What if I want to change something in that code? That would make me go to 60 other places to see, okay, does that code work? Can I change it? Is it intended the way it is or not? And that's not doable, right? So if you keep your coupling low, you won't end up with shotgun surgery. And shotgun surgery basically is you take a shotgun, you fire at it to do like a feature, and the hail hits all kind of classes you wouldn't figure. And so that's basically what happens. So we've all been there, right? So you change something and it has an unwanted side effect, and the day after you come to the office and somebody says, yeah, you broke that. And you weren't aware of that actually. So in order to reduce all of this, you need to go for high cohesion, low coupling, basically. And the thing is, like in a monolithic system, it's usually the other way around because the boundaries aren't that clear, right? So what you see here, for instance, this is a sort of a representation of a monolithic system. The color things should go together. They should be in one domain. They should only know probably the same colors. And what you see here is that all of the colors, all of those domains know each other, and they're all tightly coupled. So if I change something here in the corner, it could have an effect on that green dot there in the top corner, right? And this is what usually happens in monolithic systems because they don't have natural boundaries by themselves, right? You put everything into one big code base, you can reference everything from all over the place, even if it's not applicable. So maybe it's sort of applicable, but you actually needed to create another object. But you don't have the incentive to do so because you already have a domain object doing that thing. You just reuse it, right? So that's the thing I don't 100% agree with Victor on. He was saying, so don't repeat yourself, right? He was saying that. And I agree to a certain extent. So you need a certain level of repeating. So for instance, you have an account, but an account is different in a single service than in another service. Yeah, you're not going to reuse like that entity because it's a different entity. It has a different context. Just create an account entity in that other service as well, right? And people think of that, of repeating code, duplicating code, but it's not. So it sort of depends on when you need to keep stuff dry or not. So thing is, so strive for high cohesion, low coupling. So this is an example, for instance, when people do microservices, but the domains aren't set up correctly. Then you see that the cohesion is very low in a single service, and that there are a lot of lines between those services. This is actually not what you want. You want something like this, right? Because this is sort of, they all tend to gather here in this service. They all do a single task. and then maybe there's a connection to another service, but it's really fairly lightweight. It's usually also a lightweight protocol. So try to reduce coupling. By the way, also if you go too far with don't repeat yourself, you're also creating coupling, right? So keep that in mind. Every time you think, okay, I'm going to centralize that, I'm going to put it in a library, you're going to use it, you're going to introduce coupling. So that's something you need to keep in mind when or when not to do that. So yeah, you got an audience, right? When you write code, you don't write code for yourself. You write code for your colleagues, in the future. Yeah, you've seen the metric. So this, I'm going to go over this slide pretty fast. If the number of what the fucks basically defines how good your code is, right? So what are the consequences actually of writing code like this? So for us, it was pretty obvious, right? So we had those big customers all over the world, and they all wanted features from us. So yeah, what we did was write features. But at one point, the code base was so big, so massively badly structured, that we ended up with a train wreck. Because the only thing we were doing was fixing bugs. So we weren't writing features anymore. We were like a company, I think we had like 40 developers at one point, and roughly, I think about 25 to 30 of them were just fixing bugs. And a couple of them were writing some features and introducing new bugs, by the way. So this is what happens, right? You get into this like repetitive problem where with the more code you write, the more bugs you introduce, and at one point you get into a standstill. So yeah, bugs go up, changes become harder, and at one point your time to market will definitely go down. Your competitors will be faster if they don't have this issue, and at one point you'll just be out of the market, right? Out of competition. Good thing is that they actually sold the company before that could happen, so it wasn't a problem. Now, you'll probably think, okay, then I have this problem, I have this monolithic system, I'll just refactor, right? But that's what we do, right? If we have an issue, we will refactor. Thing is, that code I just showed you, it wasn't tested, obviously, because it had a cyclomatic complexity over 100%, number was over 100. So that means we would have had 100 tests just to get a grip of that function. It wasn't tested at all. So the thing is, in order to make sure that your code still works, you need to have tests, right? So you can only refactor when you have tests. Basically, at least refactor with the assurance that the code will still work after you're done. But in order to write tests, you have to refactor the code because that code was untestable. So this is called the legacy code dilemma, and this is where people often run into this. And it's actually not a dilemma, it's more like a paradox, right? Where do you start? You need to start with the test to refactor, but you need to refactor to start with the test, right? So this is sort of the issue you run into. So enough about what can go wrong. So what direction should we go to then? If chaos and complexity isn't the solution, it's actually the problem, what should we do then, right? Now, it's actually pretty easy. You should write easier, simple code, right? So I would vouch for let's make software development simple again. Try not to make stuff too complex, overly complex, and just try to do the bare minimum and keep it easy. So what's simple code? One of the characteristics, obviously, is that it has low coupling, high cohesion. It's easy to read, it's easy to adjust, shorter is better, and no premature abstractions. I want to also stress that. So people often think, well, yeah, well, I can abstract this because I'll have another implementation in a bit, so I'll just make an abstraction out of it. But don't, just only do it when you need it, right? When you make like a third implementation or something, then think, okay, what are the characteristics? What are the overlapping characteristics? And can I actually abstract this or not, right? So which leads to Yagni. Don't write code you think you might need at a certain point. Just don't do that. Just only write what you need. So what goes well with writing easy code, in my opinion, and writing well-structured code, keep the boundaries clear, right, is a microservice. So Martin Fowler said in 2015 or 14, I believe, that a microservice is a suite of small services running in its own process, so independent, communicating through lightweight protocols. This is important because the communication basically is the coupling between your services, right? And if you keep that lightweight, then you reduce the, how do you say, you reduce the effect of the coupling actually. So something like HTTP is fine, or gRPC or whatever you're using. Use that as a mechanism to communicate between services. Your services should be structured around business capabilities. So that this leads to higher cohesion, right? Single capability in a service, the cohesion in that service is high. So if you keep it in single business capability per service, you're good. And very important, they need to be independently deployable, which means that I can make a change in a single service, push it to production without bothering the entire other services with it. I can just write really small changes and push it to production directly. If it's not independently deployable, then yeah, it takes too much time in order for you to continuously integrate. So, and yeah, obviously you need to do that by fully automated deployment machinery, because it's foolish to do 40 or 100 or how many services you have by hand. So again, the high cohesion, low coupling, right? We already tackled that. Short history on microservices. So I'll just point out a small highlight. So in 2012, actually the term microservice was sort of introduced. It wasn't the beginning point of microservices, right? Netflix at one point, they had like a monolithic system. And they had this issue where they used one centralized database as well. And somebody put in a semicolon in the database. And at that point, the system wasn't expecting that, right? Some piece of code took that and saw that as a break, right? And stopped the entire flow of the code. Their entire system broke down. And it wasn't even an important part of their system, right? Which is delivering movies to people. It was something stupid. And at that point, the entire Netflix platform went down, just because they had a monolithic system tied to one database, and everything was tied to each other, so that thing just broke. And at that point they said, yeah, well, this is not the way to go, right? We need to split that up in order to reduce the risk if something happens in like a single service, that it breaks our entire landscape. And then they actually started to move pieces out of their system and move into like a smaller service-oriented system. And they actually started to adapt a microservice pattern. This was followed in 2013. Docker released at PyCon, really important, right? Small containers in order to get those services up and running. That really helps. And in 2014, it was Fowler who published an article about microservices. I got the quote from that article as well. And yeah, in the decade which followed, it's sort of the slope and enlightenment, right? People started to adopting microservices and started to use it and started to see the benefits of it. So that's where we are right now. We're sort of past the slope of innovation, and it's sort of becoming like more like a standard practice for certain companies. So my first experience with microservices was in 2015. So we were in that building, right, with the monolithic system. It broke down, and we were like, yeah, what do we need to do, right? So we actually went to a conference in the Netherlands at that point, and it was a talk of Sander. And I was there with the boss, and we were like, yeah, maybe we should ask this guy to come and take a look at our train wreck and to help us get further, right, to solve the issues. So we actually hired him to first analyze the problems we had, and then to help us actually try to solve them. So yeah, he did, and he actually said, okay, yeah, you need to do this, this, and this. It's a good fit for microservices. You need to try to program in this way. You need to test your code, automated pipelines, all of that. And we started, right? So, and same goes with how we started with programming. We also started our microservices like that, because you have to learn stuff, right? So we made all kinds of mistakes. So the first iteration was what I would call the iteration of chaos. It was still a big ball of mud. We had all kinds of microservices, one big application, which is also a single point of failure, right? And a single database, which is also a single point of failure. Remember the Netflix thingy? If their database went down, everything went down as well. So we still had an issue. So we started simple, but it wasn't good enough. Still had issues. Then we started to add complexity in order to solve that. And we started to do stuff event-driven. But I don't know if you guys seen the talk of Hugh. He was actually talking about, yeah, you can do event-driven stuff, But if you put stuff in the database first and then put a message on the Kafka message bus, you actually run into that you call it the area of doom, I believe. So we actually went into that area of doom. We made the entire thing event-driven, and at one point something would go wrong, and nobody would have a clue what happened, right? There was just a message, and it wasn't processed, and it got stuck somewhere in limbo. And we actually, this went into production with customers, and then I think we reverted it after like a week or something, because it was a total mess. So yeah, another iteration, and this is what we're currently doing at the company I work for right now, which is iBoot. We basically don't only make microservices, we also make micro apps. So that means that we make really small pieces of front-end code built around one business capability, which calls maybe most of the time only one microservice, sometimes two. And they all have their single Mongo collection as a data store underneath it. So this is fully independently scalable, right? If this application needs a bit of more services because it's called a lot, then this thing can scale without these services ever noticing, right? So this is what we do right now, high level. I'm going to show you a bit of the code a bit later in the presentation, but that's what we do. And in order to build these services, we use an open source library, which we build ourselves. So I think it's later on the sheet. So it's an open source library. The tagline is that it is the easiest framework to build robust and stable microservices. It's not Java, it's TypeScript and Node.js. So yeah, most Java developers also would get away with it, I guess. I have a background C#, by the way, and for me it was the learning curve was okay. So there's 16 contributors working on the open source project at the moment, and it's evolutionary architecture. So I think, Sander, when did you start with it? Yeah? When? Yeah, okay. So over the process of 6 years, it evolved through different companies as well. So it started with a Dutch insurance company using it. I think they're probably still using it. There was an insurance software supplier, IoT scale-up used it, supplier in logistics, and now obviously the company we work for is using the framework as well. So the architecture of Easy. So a single microservice. So how does that look like? Well, the main thing is it's built around an onion-like structure. So at the heart of the microservice lays the domain. We also use a bit of domain-driven design. In the domain lies your domain objects and stuff like that. Above that, we have a process layer, which basically defines the use cases we support in the service. So we actually also call the classes in the process layer our use cases, because they are. Above that, we have the service interface, which is basically the APIs, the outside communication into the system, go through that API layer. And then below we have a data layer, which is how do you say that? It's sort of removed from the other code by the domain layer. So this is the only layer talking to the data structure, to the data layer. Yeah, and outside we have mobile apps, web app, everything outside dependencies are on the outside, right? They're not really a part of the Easy microservices. So in your domain, you usually have your domain entities, right? Which are your objects, can be a full-blown entity, and sometimes we do some types. If we want read optimization, that's a different thing. Value objects, enums, all that kind of stuff. Then on the outside layer of the domain, you have your repositories or your typos. I'll tell you what typos are. It's a bit strange probably for people to see that's a typo, but it's not. So this layer is sort of responsible for communicating with the data, and then also the use case layer communicates with that layer again. Yeah, the outside data layer, that can be anything, right? From another API you're calling, or Mongo, or whatever, right? It's just the outside. It's just the thing which provides data to you. Then we have the use cases, which have the procedural steps of the thing you want to do, right? So you have a business capability, it has some steps. That's where the use case comes into play. That's the procedural part of your code. I'm going to show you some examples in a bit. Then we have the service layer, which has the resources, obviously, which are the APIs. It's your contract. So if you keep those stable, this is very important, right? You need to keep that layer very stable, because that's your outside communication with the outside world. You can change anything you want inside of here, at least if this is stable and idempotent, then you won't have an issue. So keep those interfaces stable. You can extend stuff, you can add stuff, but you cannot change stuff because you might break something, right? That's where your coupling comes into play, because it will connect to that interface. It's really important to keep that stable. External details. So I'm going to show you some code to give you an idea how it looks like. Wear my glasses, otherwise I won't see. Okay. So I made a small example. It's let's put it on another screen. It's a small movie database. So I like movies, so watch them a lot, and I have like a library of movies I like to watch. And for this example, I made something to show you how easy it is to build like your own movie library with our library easy. So the thing is really easy, right? It shows a list of movies. You can look at some images. You can get some more information. You can remove it from the library, or you can search and add stuff to the library. So I'm not a front-end developer per se, right? I'm full stack, so don't look at how it looks. It's just to give you a rough idea. So I can search for a certain movie, for instance, I don't know, Terminator, whatever. It will search using a single microservices, gives back some results. I can click it and it will add it to the list, right? So this is basically what the app does. It's really, really simple, really easy. So in order to write that, I made two small services. One service which will do all my CRUD stuff on my movie library, which is basically the movie library service, and another service to get the information of that certain movie, right? So I think I'm going to duplicate the monitor. That will actually probably work best, hopefully. Yeah. Is this readable, or should I make it a bit bigger? Yeah. Bigger? Yeah. Make it bigger here for everything, right? Well, I'll just scroll. So, the structure. So this is a single service, right? You'll see the structure of the onion that is repeated here in code by folders, right? So we'll have a data folder, domain folder, process folder, service folder. And this is here because I didn't want to build a library. We have some libraries with some default utils at iBoot. And for now, for the demo purposes, I put this in utils. So I'm not going to show you that. There's not that much in it, by the way. So in order to start the service, we built something around Express, which is a web server we're using. And basically, the only thing you need to do to start that web server is define which resource you have, and you need to define the service, obviously. So that looks like this. This is what we usually put in a library as well. So all our services are defined in a library, and it only has a name and a certain port it will run at. And then going back, in order to start the service, the only thing you need to do is say, okay, I'm the movie service. I have two resources I want to expose to the public, and just start it, right? This is sufficient when you're using Easy and writing your microservice. Then those resources, I'll click one, for instance this is the Plur one. This is where you'll get all your movies and you'll post a new movie. It looks like this. Let's do this one first, yes. So basically what we do is we make this resource and we decorate it with a route, right? This route basically defines the path you see right here, right? The path of your endpoints. We do that via a decorator, and those decorators we also put in the library because we also use them, for instance, if you want to go from another service to, from service A to service B, you want to write a gateway, and we built that gateway around that URI as well. So we basically have a library of endpoints which are used to expose on the Express web server, but we also use it to communicate in between services. So it's just a single decorator is enough to define that you have a movies route. Then you see that we have some decorators for the HTTP verbs. So basically saying, okay, this is a get function. Oh, it's small again, right? This is a get function is enough to basically get this endpoint running. We also added all kind of stuff here, so you can do cache control inside of it. You can also do custom error handling if you want. You can do custom, for instance, you want another status code, for instance, 201 if something is created, right? That's out of the box, by the way, but you might have another idea that you want another status code. You can all configure that in that single decorator. And the decorator isn't easy. Post, it's the same. And as you see, we don't use dependency injection. We use a version of control, but really basic, right? They call it Poorman's dependency injection. It's because basically you're saying, okay, I have an outside dependency. I'm going to inject it with like a default instance. In this case, the service, right, will communicate with the use case, right? The default implementation is here, but if I want to write a test, it's really easy for me to just put a mock in there and just mock the outside, right? So that's why we do this, for testing purposes, obviously. So, going to the use case layer, it's nothing more than this. So all basic CRUD operations, including searching, creating, updating, deleting, they are there's a generic a way to do that and easy. So we basically built something generic around the domain, about movie in this case, where you can do all your basic CRUD operations. So you don't have to write any code. So this is the only code I had to write actually was this resource, right? And define which endpoints I have, and that's it. And this will handle all the CRUD stuff for you. Same goes with the repository. Don't need anything else. Just saying, okay, I'm a repository. I have my default repository methods. The domain object I will expose is movie in this case. And I'm communicating with the movie gateway, with the data layer. If you want to do more, right, like more business capabilities, you would extend these methods. But just for your basic CRUD, this is enough. This is sufficient. And then the data layer. This is a specific gateway which goes to Mongo. So we've written all kinds of gateways for you, so you don't have to write them yourself. Just saying this is a Mongo gateway with some small configuration, which you put in the end, is sufficient for this to work. So it's just a matter of extending it, putting your own credentials in an env for in like a key vault store or whatever, and adding that's sufficient. We also have implementations of SQL, for instance, and file, whatever. We have multiple gateways you can use out of the box when using Easy. Also service gateway in order to call other services. So, and then the most important part actually, it's the heart of the service, is the domain. So in this case, my domain object is the movie. Basically, it has some properties. We created an entity. We always strive for immutability, right? So if you create this and you want to update this, there's a merge function on the entity. I think it's implemented if I'm correct. In this case it's not, but you should always, if you change something, you should also always return a new entity, right? So if we want to change something here in code, we would basically do that by calling that update method and giving back a new instance of that movie. So you see that we also have all kind of decorators on the field. So if it's required or if it's not empty, or the rating should be between 0 and 5, for instance. All these decorators are in Easy as well, so you can just use that and you don't have to write custom code to do your validations. The repo, what the repo will do if you create an object, it will basically build up the domain object from scratch because it's generic. It will then call the validate function, which will go through all of these decorators you put on there, and it will check if your object is valid or not, depending on the decorators you put on there. And because it's open source, if you're missing a decorator, you can easily extend it, add it to the library, create a request, and we'll add it, and you have your own decorators in there as well. So this is sufficient just to get that library and add stuff and move stuff. you don't need to write any more code for it. Yeah, obviously we also have some libraries for testing. So you see that I've written some tests, but because there's not many code in here, right, for CRUD functions, I don't have to write that many tests. The simple test I'm writing is that you actually see that some parameters get passed, and that's basically it, right? So this is probably the, Jesus, why is that selected? This is the only thing you need to test, basically, right? So if I call a by ID, is that ID I send in the request actually going to the use case? That's it. So you see, it's fairly simple code, right? Everybody can read what is going on. There's not much there, and it's easy to use. Yeah. So one more thing I wanted to show you. Last thing. So what's the benefit from this, right? Having this in place. So I used OMDB, which is a movie database, in order to get the movie information back, as you've seen in the application, right? I searched for Terminator and it gave me some results. I actually, when I did this talk a couple of months ago, and I made the two gateways in order to show that. Actually, when trying it out again, I think 2 days ago, I actually found out that one of the gateways wasn't working anymore. So they changed something, and large an issue. I was like, yeah, wait, maybe I'm going to leave the bug in to see how easily you can switch between providers, right? Because we abstracted everything, and we put everything into separate layers. It's really easy to switch, for instance, this provider. It's just a single line of code. Actually, 2 lines of code I need to switch, right? So when going from, I actually fixed the bug, so I can show you. But at this point, I'm using OMDB, right? You see that I search for Terminator, I get back some results. Oh wait, I didn't add it. So let me do that again. So I'm going to add Terminator 2. Oh, it's already there. So you can actually see that it actually found it, right? But what if I want to use another provider? For what reason? They might give you better results, right? Or I even made a GPT implementation. I couldn't get it running 100% in like half an hour, so I stopped. But still, what if I would switch to another provider, right? It's just as easy as going into that service, going into the repository, because there you choose which gateway to use, right? Switching to a different gateway. This is a different provider. It's called TMDB. Oh, wait. Do that. So, and this basically, because this is a typo, it's a repository which works with types, so not full-blown entities, right? This is for read optimization. The object here is called meta information. It's a type. It's you don't build up a full object. You just have a type, right? So the only thing I need to do is map that data coming back from that service to my type, because the data will be a bit different because it's a different service. So we've written some mappers for that, where you can actually map the JSON you're receiving back onto your type. That's basically it. This isn't easy as well. So you might know AutoMapper or other mappers. This is basically a mapper we've written, and it's an easy mapper, and you can use it as well when using Easy. So I switched to another provider. I input another mapper to map the data. Come on. Yeah, like this. Restart the service. So think of this as a change, right? You do this, you push it, it goes through your pipeline, it goes to production. It's the same as me clicking the start button again. I can go to the service, and because it's structured around that domain object, and I only need to change the repository basically to communicate, all of the other stuff still works, right? So I can search for Terminator again. You see I get different results because it's a different provider, right? Just by switching those 2 things. Then if I click it, I'll add it, and you see that the information should be different. It's hard to see, but you see get more text. You see that the actors are a bit differently ordered. So you basically see that with this system, and if you structure it that way, because you have high cohesion, low coupling, use the microservices, a well-structured code, with 2 single small changes, you can actually do something entirely else with a different provider. So I guess that's the benefit from doing this. You can easily change. So that's the demo part. Let's see. Extend again. Oh, it's the other way around. forgot the shortcut to go to a certain page, so need to go through this. Yeah, go. Yeah, codes, show you the live examples. Yeah, so recap. Try to reduce complexity for the reasons we all talked about. Try to start building easier code. Maybe even try our library. If you're doing microservices, why not, right? You can just build a microservice in a certain way without it being an issue for your landscape, right? So I would just advise you all to just give it a try. Maybe help, write some code in the open source library. And yeah, that's it. That concludes my talk. So I don't know if there are any questions or remarks, or feel free to ask them. And otherwise, I would like to thank you all for joining.